Welcome. Today is Lazy Sunday, October 23rd, 2022. We discussed the advantages of having my theoretical particle, the GP1, elastic compressible ether particle of mass. Oh, yes. I love my theoretical particle because there is so much we can do with it. We can explain how matter and energy is stored in the neutron sac, in the proton sac, in the electron permeable sac, in the neutrino permeable sac. Okay, so what we do is what is done in nature. Okay, GP1s, God particle ones. I defined them. I thought them up, but they are not a fictitious particle. They are a physical, actual particle. And with this physical, actual particle under pressure throughout the entire finite universe of perhaps 28 billion light years across, okay, we have a large universe. It's probably at least 26 billion light years across, okay? 26 billion light years. And throughout these universe are God particle ones. And these God particle ones, gaseous particles, must be under pressure. So this is how our universe evolved. In a finite volume, approximately 26 billion light years across, at the beginning of time, GP1s formed and filled up all of this space that is now our universe, okay? And this space is developed or had managed matter and energy reflective edges. So we have a universe of finite volume, and this universe is full of God particle ones. And then a little bit of motion developed. I mean, we are given that entropy, which is disorder, okay? So you have a homogeneous GP1 across 28 billion light years. And some motion developed, and over infinite time, this created a higher pressure at the center of the universe. So at the center of the universe developed a higher GP1 ether pressure, and this higher GP1 ether pressure at the center of the universe caused the GP1s to form into strings. And as they formed into strings, the entropy increased and the pressure increased. So as more strings formed, the entropy increased and the pressure increased. And then the whole universe may have gotten up to 1 hertz, not 1 gigahertz, not 160.4 gigahertz like we have now. No, it had a pressure. It developed a pressure of 1 hertz. So you have to understand that the universe is infinitely old, okay? And it's going to go on forever. And that the fruit does not fall far from the apple, okay? So in the center of the Virgo cluster, okay, our local galactic group orbits the Virgo cluster. We are continually falling. We are gravitationally bound to the Virgo cluster, our entire local galactic group. At the center of the Virgo cluster is M87, and M87 has a supermassive black hole of 6.5 billion solar masses. Now, what I say is that our local galactic group is an offspring. It's an offspring of an offspring of an offspring of an offspring of the 1,000 galaxies in our Virgo supercluster. I say that the 1,000 galaxies in our Virgo supercluster came from M87, okay, over infinite time. So M87 has been around, and we know this must be true because it could not grow. It could not grow to 6.5 billion solar masses. That black hole can't do it in 15 billion years, can't do it in 150 billion years. It takes more than a trillion years, okay? More than a trillion years, and it could take hundreds of trillions of years for Andromeda to become the galaxy and the local galactic group that it is from a star cluster in M87. So from a star cluster in M87 that went out and formed other galaxies and other local galactic groups, okay, then there was another star cluster that broke off and made galaxies, and then eventually the Andromeda galaxy went out and it made dwarf galaxies, may have made the Milky Way galaxy. The Milky Way may be an offspring of Andromeda, an early offspring. So we know this by the size of the black holes. Andromeda has a supermassive black hole of 120 solar masses. So that means it's much, much younger. We're talking trillions of years younger than the supermassive black hole in the center of the Virgo cluster. Now, you're only going to hear here, okay? If you look at galaxies, you'll see that galaxies resemble hurricanes, okay? Hurricanes. And the reason they do that is because they have similar functions, okay? So we discussed before, okay, we just proceed as if electromagnetic waves have all the properties of sound waves, and since they have all the properties, then electromagnetic waves must propagate in a gaseous medium, and that gaseous medium must be under pressure, and it's invisible because it's so tiny we can't measure it. We can only measure to the electron neutrino, which has a mass of 1/1,000,000th the size of the electron. Now, once you go below the mass of the electron, they've developed a thing they call sterile neutrinos. Okay, now the GP1 that I envision is even below the sterile neutrino. Okay, it's about 1/quintillionth the size of the electron. Okay, 1/quintillionth. That's a lot of zeros. Okay, it's very tiny. Okay, now recently, Bananas at Fermilab in a discussion or a debate, okay, they brought people from the past. They got actor physicists to play the people from the past. I think it's Bananas neutrino oscillation, and they debated the issue of the sterile neutrino. The sterile neutrino that cannot be seen and as a candidate for dark matter. Well, their dark matter is a problem for them because, yes, the neutrino and maybe even the sterile neutrino does generate dark gravity, okay? But what they don't know and will never know, is that gravity is a function of matter heating up. It's a function of nucleons heating up. Okay, now that we can see and that it's done. Okay, so nucleons heat up, but they don't know how nucleons heat up. They don't heat up the way as it's described in thermodynamic theory by getting a bigger bounce. What gets a bigger bounce is the GP1s. The GP1s get a bigger bounce as more GP1s are net imploded into permeable nucleon sacs, are net imploded into permeable electron sacs, are net imploded into the neutrino oscillations. And if there is a sterile neutrino that they can't measure to, I mean, the GP1 is like a sterile neutrino, okay? So these are sacs, and my theoretical particle is a physical particle, and it's physically inserted inside the proton permeable sac. It's physically inserted. Electromagnetic waves are beads of compressed GP1 high pressure and vacuum, okay? High pressure, vacuum pressure, high pressure, vacuum pressure. And that's against the standard pressure of the cosmic microwave radiation. Now the Casimir effect, and they know. So I only differ in the description of what gives the GP1's pressure, okay? Physicists know that empty space has a pressure, but they don't know what is pressed together. So the way they measure pressure, the way physicists measure pressure in empty space has to do with the hertz, has to do with 160.4 gigahertz for the CMBR, and that translates to a certain joules, and you end up with a pressure of 0.901 joules, okay? That's a very tiny amount of energy, but that's the pressure in empty space, the pressure between the GP1s, okay? And that pressure goes throughout the universe, okay? The expanding, accelerating universe is impossible. You cannot have energy without having matter, okay? So electromagnetic waves, the frequency and the strength evolved as GP1s got woven into strings, and the strings got woven into sacs, and the smallest permeable sac of mass that we can measure is the electron neutrino. Now that electron neutrino oscillates to much bigger sizes, okay? And what I say is that over infinite time, and as the pressure in the center of the universe increased, as the entropy increased, the matter and energy reflective edges of the universe, okay? Now, quick, so you know, I'm telling the truth, okay? The CMBR is omnidirectional. What that means is every point in space is sending to us the same electromagnetic wave frequency, and there are no stars at that point, okay? Between us and the edges of the universe, okay, from an edge of the universe, a spot in the edge of the universe that has no electromagnetic, has no stars or galaxies at that distance, the CMBR is shot to us. Now, the physicists can't have it both ways. Energy can't pop from a singularity and also pop from every point in the universe envelope. Okay, it can only pop from every point if electromagnetic waves generated in our universe, and we got all sorts of different frequencies, and those electromagnetic waves from point sources, from galaxies and stars, those point sources, gamma rays, X rays, radio waves. Okay, so radio waves have a lower frequency than the microwave. Okay, so some waves are homogenized to a higher frequency, and X-rays are homogenized to a lower frequency as they bounce back and forth from the edges of the universe. So electromagnetic waves, the CMBR is the net homogenized byproduct of all the electromagnetic waves produced by our stars in the universe as they bounce back and forth from all the edges of the universe. So, okay, so I don't know how people can tell you about the Big Bang. I mean, there's no energy is stored in matter. That's a given. And if there are a lot of neutrinos out there, there can be more energy and matter. Okay. I say that the energy and matter stored inside of permeable proton sac is in the form of compressed GP1s. There's a physical medium for electromagnetic waves. There's a physical GP1 inside the indestructible proton sac and the indestructible electron sac and the indestructible neutrino sac that can be blown up to a tau neutrino. And over infinite time, that tau neutrino can become an electron. And over infinite time, that electron can become a quark and an up quark. And then when you hook up an up quark and an electron together, you get a down quark. More on that. More on that the down quark is a combo. It's a combo between an indestructible electron sac and a destructible up quark sac. Talk more soon. Like if you like. Thank you so much for listening and have a wonderful day. Bye.